Hello and welcome, guys. It's been long since I posted the last video. Almost 4 years have passed. I think last video we did was balance parentheses, so I want to continue from there and complete the series for once. So today we'll be seeing this queue problem. So basically, queue is a data structure which follows first in, first out principle. And in this particular problem, they are asking us to create a queue using two stacks, and they have given certain queries which we need to perform. So we need to enqueue, that is adding into the queue. Dequeue is popping out of the queue, and third is printing element at the front of queue. So from here, let's move on to the explanation part, how we will do it. And after that, as always, we can go for the code. Now we all know what queue data structure really is. It's a basically FIFO, that is first in, first out. So whenever you see any queue in bank or coffee shop, that's the exact working of it. So in one side we will push elements. We can call it push or enqueue. On the other side we will pop the elements. That the stack terminology or DQ. That's the queue terminology for removing the element. Or we can always do the print, peek or in stack we used to do the top. So whenever we want to check the last element or the first element which needs to be removed in a queue, we will do the peek operation. So current problem says that we need to solve this, or we have to mimic this particular design using two stacks. So let's try doing that. So let's take two container. Let's call this stack one. Another is stack two. And we have to do certain operation, that is first is enqueue, then dequeue, and third one is, I guess, peak. So we have to do this operation in certain way that it mimics the original queue data structure. Okay. So for enqueue, what we will do is we will directly push whatever element coming to our way directly into a stack one. So enqueue is very simple. Whatever element comes to us, we will push into stack one. For dequeue, however, what we need to do is we have to use for dequeue and peak, we will use this stack and we'll check if this particular stack is empty or not. If it is empty, we need to do certain things. And if it's not empty, we can directly perform the operation on it. So let's take example given in this particular code. It needs, so first it asks us to insert element 42. So let's say we will use the first stack, we will add element 42. Now, second operation is to DQ. We have to remove element. So as I said earlier, in case of DQ or peak, what we will do is we'll check first if stack is empty. Stack is equal to empty, or if that is the case, if empty, we need to transfer elements from first to second. If in case of empty, if no, let's say stack is not empty, then we can do perform operations on stack 2 directly. So let's get back to the performing operation. So we need to dequeue. So what we'll do, since stack is empty, we'll remove this element from here and we will perform insertion into this particular, that is transfer. And after that, since it's a dequeue, we have to remove that particular element as well. So dequeue will be like pop operation. Okay. And after that, the third operation is 114. So we need to insert element 14 into the stack one. NQ is fairly simple. After that, it asks us to print the top element. So again, the stack is empty. What we need to do is we need to transfer this element into the stack 2, and then we can do the print, that is print top of the stack. So our first output will be, that print output will be 14. So we will maintain output here. After that, the third statement is 128. So we need to insert element 28 into the queue. So let me quickly remove this clutter. Okay. So we will add element 28 into the queue one, stack one, sorry. And 14 is still on the other side of the stack. After that, it again asks us to print the element, that is 3. So in this case as well, since our stack is not empty, we need not need to do any certain operation. We will check not empty and what is the top of stack, 14. So we will again print 14 here. After that, there is in operation 160. So we have to insert element 60 into the stack. So we will insert it here. After that, again, there is request of adding element 78 to the stack. So we will again add 78 to the stack one. After that, there are two operations, that is DQ and DQ. So in this case, so in the case of DQ, since our stack is not empty, we'll remove element 14 from it. So first case is done. So first two is done. After that, it again asks us to do the DQ. So in that case, what we'll do transfer of the elements. So it will basically go from the top. So it will be like 78, 60, 28, and it asks us to do the pop or the second DQ operation. So we will remove element 28 from the our stack, and the remaining elements will be 60 and 78. So the 28 was added earlier and it got removed earlier. So we maintained the queue philosophy or queue data structure here. So basically, what we need to understand is whenever we get NQ, add elements directly to stack one. There are no ifs and buts question. Directly we have to do the operation. In case of DQ, however, or peak in this case, check emptiness. If yes, then transfer and perform operation, that is pop or peak. If stack is not empty, we can directly perform operation like pop or peak. So you need to understand these things only, and that is the whole crux of it. So let's move to the code, and I'll help you write the code, and we can close this problem. Okay, let's start with the code part. Earlier, I used to do coding in CPP, but those days are long gone. Not sure I will be able to do code in CPP, so I have chosen Java. I'm currently working in Java. So this is basically stuff. So we have performing operation as provided by them. So the main part is here. So we have to take two stacks as discussed earlier. First stack will be for the insertion operations, and the second stack will be for DQ or printing element. Okay, as discussed, for NQ operation, we will push the elements into the first stack, and whenever we have to DQ, as discussed, we will first check if that is the second stack is empty. If yes, we will do the transfer, and if not, we will pop the element. So transfer is basically transferring top of the element from the stack one to the stack two, and this is the basically peak that is check the what is the topmost element or the first element to be removed from the queue. So this is the basic code. I'll add this into the description. We can submit and check if this works. 15 test case is huge, I guess. I'm not sure. So, okay, it passes all the test cases, which I also checked earlier, so it's not a big deal. And this is a fairly simple problem. And lot of interview question can be asked around the implementation of stack, queue, and vice versa, like how stack can be created with queue and how like this one, like queue can be created with two stacks. So we will cover more problems in coming days. So stay tuned.